Hello, my dear pilot students. I hope you're working hard to achieve your dreams of flying the big jets. And whatever little contribution I can make it towards that goal, I shall be too happy, too delighted. We have done a number of numericals so far in navigation. And today, we are going to start with the radio navigation aids. Okay. No need for me to emphasize the importance of this subject. You all know it by now. And to understand radio navigation aids, we must first understand the basics terms which are used in the radio transmissions. The basic terminology is what we are going to read now. When you throw a stone in water, it creates waves which spread around. When an island has an earthquake, it sends out huge tsunami waves. These waves travel a long distance. When you give alternating current to an antenna, it sends out electromagnetic waves in the air. And distance covered by one cycle, like AC, alternating current, this radio waves, also called electromagnetic waves, also have a cycle. And any particular stage of that cycle is called its phase. The distance covered by one wave in the atmosphere is called its wavelength, represented by lambda. Unit could be inches, centimeters, meters, etc. The number of cycles per second is known as its frequency. And frequency of one cycle per second is now called 1 hertz. Speed of the radio waves is fixed, also called electromagnetic waves. They travel at the rate of 3 into 10 to the power 8 meters per second, or 300 meters every microsecond. 1 microsecond is 10 to the power minus 6 of a second. That is 5 zeros and 1 seconds decimal. And 1 nanosecond is 8 zeros and 1 seconds decimal, 8 zeros, 1. And that is 10 to the power minus 9 seconds. Since the radio wave speed is very high, all numericals in radio aids will be done with these units. And 300 meters is roughly 1/6 of a nautical mile. Okay. 985 to be precise. The speed of the radio wave is equal to mathematically wavelength in meters, please take note, into frequency in hertz. Speed is 3 into 10 to the power 8 meters per second. This is equal to wavelength into the frequency, and if one is known, other can be calculated. Speed always remains the same. Right, we will do a few numericals on this concept, which are also asked in examinations. Right. Radio waves have a property when they travel through the air, they are reflected back by the solid objects. And this radio wave transmitted by the transmitter after hitting the object, in this case we've taken an aircraft, is received back by the same transmitter by a aerial, which is transmitter and receiver aerial. It has got a orbiting aerial. A radar has got a orbiting aerial, directional aerial. There are two types of aerials. One is a omnidirectional. Aerial is in the center. Signal is sent out in all directions. Omnidirectional. Other transmission is called directional, and it has a beam, and this is called beam width measured in degrees. So when this radar is rotating, when it is pointing towards this direction, the direction will be known, and the radar will calculate the distance that the echo was received in so many seconds. Half of that time is one-way time multiplied by the speed gives you the distance. That's how a normal radar works. We'll study it in detail when we come to the radar lessons. Next, depending on the frequency, these frequencies are divided in frequency bands. A frequency of 1000 hertz is called 1 kilohertz. 1000 kilohertz is called 1 megahertz. And 1000 megahertz is called 1 gigahertz. We'll mostly be using frequencies in this spectrum. Now, the lowest usable radio frequency, which has got the properties of radio waves, is 3 kilohertz. 3 to 30 kilohertz is low frequency, 30 to 300 kilohertz. First is very low, then low frequency, and 300 to 3000 kilohertz, which now becomes 3 megahertz, is medium frequency. And most of your radio with the tower, etc., the long range RT will be on high frequency, 3 megahertz to 30 megahertz. And with the tower, etc., you will be working on VHF, very high frequency. And most of the navigational aids also are on very high frequency, or UHF. The radars are in radar band. 1000 megahertz onwards are also classified as radar bands. L band is 1000 to 2000, 2000 to 4000 S, 4000 to 8000 C band, and X, you must have heard of X-rays, 8000 to 12,000 megahertz. As the frequency increases, wavelength keeps decreasing. This low frequency, each wave is in kilometers, and then it comes into decimals of centimeters. Right. Maximum range of a very high frequency signal is 1.25 into square root of height of the transmitter in feet plus height of the receiver in feet. For example, transmitter is at 10,000, receiver is at 900 feet. When the ground is transmitting, aircraft is receiver. When aircraft is transmitting, ground is the receiver. So 1.25 into 100 plus 30 is 1 square root height, 10,000 plus receiver. So it becomes now 100 plus 30. And 162.5 nautical miles will be the range of this ground station. Of course, range also depends upon power. And if you are more than this distance away from this ground station, you will not receive it. Next, if the frequency is given, you can find out the wavelength. Speed divided by the frequency. Since it in megahertz, convert it into hertz, into 1000 kilohertz, into 1000 hertz, and you will get 2.47 meters is the wavelength. If the wavelength is known to you, 1.2 kilometers, what will be the frequency and which frequency band? Now, 1.2 kilometers, we will convert it into meters. 3 into 10 to the power 8 divided by 1200 meters is equal to 250 kilohertz, and it is in low frequency band. Another type of a question from this topic or this today's lesson, if a echo of an object is received in 800 microsecond, what is the distance from transmitter? That means one-way travel time is 400 microseconds. In each microsecond, radio waves travels 300 meters. So total distance will be 120 kilometers. These are the type of questions, fairly simple, but are asked in examination. And of course, as usual, what about the practice questions? Now, here they are. 8 questions for your practice, and I'm sure you will get all of them right. Fairly simple, as you have seen, and I'm sure you are familiar with these words. VHF RT means VHF radio transmission, RT signals, and these are the questions. And do these questions yourself. And then, of course, you would like to know what are the answers. You must be keen to know if you have done them yourself. Now check the answers. And if any of the questions you had a problem in doing it, not getting it right, come back in comments to me and one of your friends from the group, or I will come back to you and clear your doubts. Now, very soon we shall be getting over to the automatic direction finder, VOR, ILFs, etc. For the time being, this is SK Booty here, Booty Aviation Training, and remain with me, subscribe to my channel, like the videos, and we shall continue our partnership. Bye-bye for the day, for the time being.